Good morning, students. So today we are going to discuss coefficient of multiple correlation. So in a trivariate variables x1, x2, x3 has n observations. The multiple correlation coefficient of x1 and x2 x1 on x2 and x3 denoted by capital R 1.23 means the multiple correlation of x1 on x2 and x3. So it is denoted by capital R 1.23 means x1 on 2 and 3 variables. So it is a simple correlation coefficient between x1 and the joint effect of x2 and x3. So in other words, capital R 1.23 is the correlation coefficient between x1 and its estimated value given by the plane of regression of x1 on x2 and x3. That is E1.23 is given by, we know that formula B12.3 x2 plus B13.2 x3, where x1.23 is x1 minus B12.3 x2 minus B13.2 x3, or that equal to x1 minus E1.23. Therefore, E1.23 equal to x1 minus x1.23. So since xi's are measured from the respective means, therefore their expected values are zeros. That is, expectation of x1, x2 and x3 all are zeros. So when all these are zeros, then expectation of 1.23 is also 0. Expectation of E 1.23 is also 0. So by definition, capital R 1.23. So this is nothing but a correlation. So you know the correlation formula. So apply the correlation coefficient formula. Usual correlation coefficient, that is Carr Pearson's coefficient of correlation. That is covariance between x1 and E 1.23 divided by square root of variance of x1 into variance of E 1.23. So now we find out the covariance between x1 and E 1.23. So by definition, R 1.23 equal to what? Covariance between x1 and E 1.23 divided by standard deviation of variance of x1 and standard deviation of this E 1.23. Now we find out the covariance between x1 and E 1.23. So by definition, covariance equal to what? Expectation of x1 minus E of x1 into E 1.23 minus E 1.23. So that equal to what? 1 upon n summation x1 into E 1.23, that equal to 1 upon n summation x1 into substitute E 1.23 value, that is x1 minus x1.23. Then you take 1 upon n summation inside. So when you take 1 upon n summation and multiply by x1, you will get these values. 1 upon n summation x1 square minus 1 upon n summation x1 into x1.23, or that equal to 1 upon n summation x1 square minus 1 upon n summation x1.23 square, because we know the property x1 into x1.23 is same as x1.23 only, and 1 upon n summation x1 square is nothing but what? Sigma 1 square minus sigma 1.23 square. So this is the value of covariance between x1 and E 1.23. So covariance between x1 and E 1.23 is sigma 1 square minus sigma 1.23 square. Similarly, we find the variance of E 1.23. Okay. E1.23 equal to expectation of E1.23 square minus of expected value is 0. So only we will get this much. Then 1 upon n summation E1.23 square, that equal to substitute E1.23 value 1 upon n summation x1 minus x1.23 square. Then expand by using a minus b whole square and take summation 1 upon n summation inside. So we will get 1 upon n summation x square plus 1 upon n summation x1.23 square minus 2 upon n summation x1.23 square. And substitute in terms of sigma, we will get sigma 1 square minus sigma 1.23 square. Substitute these values in the above formula. Then we will get R1.23 equal to sigma 1 square minus sigma 1.23 square divided by square root of sigma 1 square into sigma 1 square minus sigma 1.23 square. Then squaring on both sides. So we will get R1.23 square equal to sigma 1 square minus sigma 1.23 square divided by sigma 1 square we will get. Or divided by sigma 1 square you will get 1 minus sigma 1.23 square divided by sigma 1 square. So transfer R1.23 this side and sigma 1.23 square upon sigma 1 square that side. So we will get 1 minus R1.23 square equal to sigma 1.23 square divided by sigma 1 square. So understand, this is a very important result. 1 minus capital R1.23 square equal to sigma 1.23 square divided by sigma 1 square. So substitute in terms of omega. Omega is nothing but what? The determinant of coefficient of correlation between these variables 1, 2, 3. So 1 minus sigma 1.23 square equal to omega divided by omega 1, 1. Therefore, R1.23 square equal to 1 minus omega upon omega 1, 1. Then omega is nothing but what? Determinant of the coefficient of correlations. So omega equal to what? First row is 1 because correlation between 1 and 1 is 1 only. Then correlation between 1 and 2, correlation between 1 and 3, first row. Second row, correlation between 2, 1, then 2, 2 is 1 and 2, 3. Next, third row is 3, 1, 3, 2, 3, 3 is nothing but 1. So this is the determinant of coefficient of correlation is denoted by omega. If we expand and simplify, we will get 1 minus R12 square minus R13 square minus R23 square plus 2 times of R12, R13, R23. Understand? So you try this one. You expand omega, you will get this value. Omega 1, 1 is nothing but what? Cofactor of 1, 1 element. That means ignore the corresponding row, corresponding column. We will get determinant of 1 R1, 2, 3, then R3 to 1. Simplify, you will get 1 minus R23 square. Therefore, R square, capital R 1.23 square is nothing but 1 minus omega upon omega 1, 1. R12 square plus R13 square minus 2R12, R13, R23 divided by R1 minus R23 square. So this is the important relation between the multiple correlation and usual correlation coefficient. So understand, capital R 1.23 square equal to R12 square, R13 square, then minus 2 R12, R13, R23 divided by 1 minus R23 square. So this is the important relation. Correct. So far we discussed only for 3 random errors. Suppose there are n variates are there in a distribution. In case of n variate distribution, the multiple correlation coefficient of x1 on x2, x3 and so on up to xn is denoted by R1 point, capital R 1.23 up to n. So it is once again a correlation between x1 and the giant effect of x1 and So once again, by using the definition, R 1.23 up to n equal to covariance between x1 and E 1.23 up to n divided by standard deviation of x1 and standard deviation of E 1.23 up to n. So once again, what we used the previous same formula we had to use and same procedure we had to use to calculate covariance as well as variance. So the covariance between x1 and E 1.23 up to n equal to what? 1 upon n summation x1 E 1.23 up to n. So that equal to 1 upon n summation x1 into x1 minus x 1.23 up to n, or that equal to 1 upon n summation x1 square minus 1 upon n summation x1 x 1.23 up to n, or 1 upon n summation x1 square minus 1 upon n summation x 1.23 up to square. So that equal to sigma 1 square minus sigma 1.23 up to n square. Understand? Same procedure we have to use. Then find the variance of E 1.23 up to n. So that equal to 1 upon n summation E 1.23 up to n square, or 1 upon n summation x1 minus x 1.23 up to n square. Then take 1 upon n summation inside and expand a minus b whole square. We will get 1 upon n summation x1 square plus 1 upon n summation x 1.23 square minus 2 into 1 upon n summation x1 x 1.23 up to n, or that equal to 1 upon n summation x1 square plus 1 upon n summation x 1.23 square minus 2 upon n summation x 1.23 square, or that equal to sigma 1 square minus sigma 1.23 n square. Substitute these values in the formula. So we will get R 1.23 up to n equal to sigma 1 square minus sigma 1.23 up to n square divided by square root of sigma 1 square into sigma 1 square minus sigma 1.23 square. Or simplify this one, you will get sigma 1 square minus sigma 1.23 n upon sigma 1 square whole raised to 1 upon 2. So squaring on both sides will get r square 1.23 n equal to 1 minus sigma 1.23 up to n square divided by sigma 1 square, or that equal to 1 minus omega upon omega 1. Same procedure we have to use what we applied. So in the previous case, we are discussing only 3 variables. Here we are discussing n variables. So understand, and always r 1.23 square is positive, okay, and 1 minus r 1.23 is less than 1. Okay. So any problems are there, we will discuss in the interaction class. Thank you.